Alright, this video here is a step-by-step procedure. We are going to conquer chemical equations, every single step of them. Okay? If you get this joke right here, you watch too much TV. 5 steps to conquering chemical equations. We're going to go through each one of them with an example. Okay? First, turn your reactants names into chemical formulas. Now, how do you do that? Write out each as an ion with its charge listed. Make sure you have all the correct ions, the elements versus the polyatomics. Use the charges to balance any compounds. And if an element is by itself, list it without charge, but put a little 2 in front of it if it's diatomic. Remember your Brinkelhoff. So let's do an example. Sodium phosphate is added to magnesium chloride. First thing I want to do is write out the ions. Na plus, PO4 3 minus, plus Mg2 plus, Cl minus. Those are the ions for each one of those. Remember, look here, a phosphate is a polyatomic. It's not phosphide. 2 ways that I can balance these charges. Okay, I can get used to the cross method here as we have with sodium and phosphates, right? So that's the way I can do it. Or, if you're more comfortable seeing it visually this way, Mg has 2 pluses, chlorine has 1 minus, alright? So I've got 1 chlorine here to balance out this plus, I've got to add another chlorine here to balance out that plus, and if you look in this box, I have 1 magnesium and 2 chloride ions, so my equation should be MgCl2. So we'll look here, Na3PO4 with the cross, or MgCl2 balancing out the picture. Next step, write out the skeleton of the equation using your 5 different types of reactions. So use this to try and figure out what kind of reaction you have. Here are all the skeletons. Okay? Special note, remember, when I'm combusting, if I'm combusting a carbon, I'm always going to produce CO2. If I'm combusting a hydrogen, I'm always going to produce H2O. If I'm combusting a compound that has carbon and hydrogen, I'm going to produce both CO2 and H2O. So if I figure out the skeleton, on this one, if I look at this, my skeleton I can see is a double displacement, an AX plus BY. And if I look at my skeleton, I know the displacement's going to happen where this A and B are going to switch, and I'm going to end up with a BX plus AY. Third step, now that I know my skeleton, I'm going to predict my products with new chemical formulas. First thing with this, make sure you do the ions first. If we have Na3 here, you're not bringing Na3 over, you're bringing the sodium ion, just the Na+. So make sure you're writing it out just like in step 1, you're writing out the ions. Then we balance. We're still working in little numbers when we are balancing formulas. Okay, not the entire chemical equation, but we're balancing the chemical formula for the compound. So if I look here, I brought over the Na+, and I've got the Cl minus, not Cl2, but Cl minus, that's the ion. I've got magnesium 2+, and my phosphate ion, which is PO4 3 minus. There is a trick to this one, which we're going to walk through right now to make sure we do that one properly. Okay, so I've got magnesium 2+ and my phosphate 3 minus. First thing I want to do, visually you can see it this way. If I write out my magnesium with my 2+ signs there, those are each 2+. So every magnesium in there, every magnesium brings 2 positive charges. Well, on this side, my phosphate ion, it's bringing its 3 negative charges. 1, 2, 3. So if I write this out, then I can go with the picture. Cancel out that charge. Cancel out that charge. Uh-oh. I've got a negative left. What do I do with this one? Well, I've got an idea. Let's add another magnesium here. If I've got a negative, let's add a positive. Okay? And that way, cancel out that one. Now all my negatives are gone. But, hey, I've got another positive. Maybe I know what to do now. Let's add another phosphate. All right, so I've added a negative. I've got an extra positive. Let's add some more negatives. And I continue doing this until I feel and I have proven that my charges are balanced. I've got 2 extra negatives here. I add a positive. And look at that. I am now a balanced compound. None of my charges are left. If I add up 1, 2, 3, 4, 5, 6 positives, I've got 1, 2, 3, 4, 5, 6 negatives. Total charge is 0. I'm happy. Now, how do we write this? I've got 3 magnesiums, so I'm going to do Mg and a 3. Okay, subscript 3. I have 2 PO4s, so the first thing I want to write is PO4. Then I put a parentheses around that PO4, and I put a 2 on the outside. So if you see, this means there's 2 PO4s. If I were to write it like this, well, that wouldn't make any sense. That would mean 42 O's. If I were to possibly multiply it, so that's not right. Some people might want to do this, that 2 times 4. Well, that means one phosphide ion, 8 oxygen ions. That's not going to work. All right, and then I can't carry that 2, and this actually is incorrect as well. Okay, so we want none of that. We want the phosphate ion with the parentheses and a 2 on the outside. Written just like that, nice and balanced. Okay, so let's bring that back in. We've got our NaCl balanced 1 to 1, and then our magnesium phosphate Mg3 PO4 2. Fourth step, balance the chemical equation using our coefficients. Now we're going to use the big numbers in front of the formulas. Okay, we're going through the whole equation. Remember, if I've got a 2 on the outside, that gets carried through. So 2 here means there's actually 4 H's and 2 oxygens. If I've got a 3 on the outside here, that means 3 berylliums, and then this 3 can multiply by this 2 and actually give me 6 nitrates. When I'm balancing, keep polyatomics together if I can on the left and right, and then try and save your diatomics, your hydrogens, your oxygens to last if you can. That'll help you out. First, set up your grid. Write every compound that's in the equation, both on the left and the right, in your grid. Then number them. Okay, over here I've got 3 sodium, so I put a 3 here. I've only got 1 PO4, 1 phosphate, so I only put 1 there. Then I look at what's not balanced. I've got an unbalanced sodium, I've got unbalanced phosphate, unbalanced magnesium. Really no right or incorrect way to start on this one. So let's just start at the top. Let's do our sodiums. If I put a 3 here, that'll give me 3 sodiums, and then it'll also give me 3 chlorides. All right, and that will help me balance out my sodiums here. Okay, that's that 3 there, the coefficient that carried it through. Now let's go ahead and go to phosphate. I've got 2 on the right, let's go on the left. If I put a 2 right here, that'll give me 2 phosphates. That also gives me 2 sodiums, but I've already got 3, so that big 2 multiplies these 3 sodiums by 2, and I go from 3 to 6. Well, that's okay. I can always come back and change. All right? So now I get rid of my 3. Instead of having that here, I put a 6 in front. And that'll give me 6 sodiums. But then I also got to make sure that I've got 6 chlorines as well. Okay. Sodium's balanced, phosphate's balanced, magnesium's not so much, chlorines not so much. Let's go to our magnesium. If I put a 3 here, I get to multiply this magnesium by 3. Look at that, nice and balanced. And it worked out pretty nicely because this 3 times 2 chlorine, nice and balanced there as well. Okay, so balancing is the big numbers. It's the coefficients. Make sure you carry it all the way through. This is different from balancing the formulas. This is balancing the equation. Last step, check to make sure the reaction will produce a product that can be observed. Single displacements, we're using the activity series. Double displacements, using the solubility rules, and then you include the states of matter. This here, as we saw before, is a double displacement, so let's go to the solubility rules. But first, to remind you, activity series here, double displacement, solubility rules here. Let's use the solubility ones as our example. Okay, so let's start with sodium chloride. All right, I find the chloride ion up here. I look at my chart. Chloride is soluble. I want to double check my exceptions. I see that sodium is not in my exceptions, so I know sodium chloride is aqueous. It is soluble. It is not a product. Let's go to my magnesium phosphate. Okay, I find my phosphate ion there. I look and I say, oh, if it's down here, that means it's insoluble. So right now I'm thinking solid, insoluble. I check my exceptions. I don't have ammonia, and then it's not in group 1, the alkali metals. So now I'm saying that magnesium phosphate is in fact insoluble. It is a solid, so I put a nice little S right here. And I have my full balanced equation with states of matter showing my precipitate here. There you go. That is the 5 steps to conquering chemical equations.